Well, hello there.
Hi, everybody.
Oh my God, this is awesome.
Wow. Hi, Velocity. I'm
What
JP.
is going on? JP, I'm Dan, and we have notes. Excellent. We're from this company over here. This is what we're going to be talking about. Terraforming a new environment for Firefox Crash Reporter.
Now, that has no intellectual property.
No, it's fair use. It's fair use.
Okay.
This is the theme. As you can see, I'm a classy guy.
He's a lot classier than I am.
Classy guys open up their talks with Shakespeare. So here we go. 2 data centers, both alike in dignity, in fair Mozilla, where we lay our scene. From ancient standards, break to new paradigm, where civil syntax makes civil code unclean. From forth the Git repos of these two foes, a trio of star-crossed DevOps engineers make their life, whose whose misadventured piteous overthrows do with their commits bury their manager's strife, the fearful passage of their markdown docs, and the continuous deployment of their apps is now the 20 minutes traffic of our stage.
Thank you, Frosty. Thank you.
No, in all seriousness, what we're going to talk about is that time we took our entire physical stack and put it in the cloud.
Sounds really easy. I know everyone's probably done it. It's just going to be like a 2-3 minute talk.
3 minutes in and out, we're done. Actually, seriously, for real, JP, what are we talking about?
Well, you know, the thing is, we're here at Velocity, and this isn't really a farming conference. You know, we don't really farm beets professionally.
Well, speak for yourself.
Most of us. Okay. And, you know, so we're going to talk about technology, of course, but the real important part that we are here to talk about isn't the technology. It's not whether we're using Go or anything like that. It's where technology and humans cross. Humans, those...
That intersection.
Yeah. Those,
people and computers.
Those super unreliable human beings.
Oh my God. Computers would be so perfect if it wasn't for people. And the way we're going to talk about it is a little story about this thing. Now, this is Socorro Crash Stats. I'm going to level with you. Sometimes Firefox crashes.
Sometimes Firefox crashes when you're using Flash. I'm sorry about that.
Mostly Flash. Sorry about that.
And so what happens is when you're using Flash and it crashes, you click a little button that says, you know, do you want to report this back to Firefox? And first of all, again, sorry, but thank you. Please do click that button because we actually do use that data. We don't want to have you crashing all the time.
Those reports don't go into the ether. We do use that to guide our development. So please submit those reports when you have a Mozilla product that crashes because Flash. So we're going to talk a little bit about this. We're not going to talk about this project, but this is the medium to explain a little bit about what we did. First off, a brief history of everything. So the entire stack that deals with those crash reports, codenamed Socorro. It's totally open source. There's a link here you can check out. Has anybody heard of Mozilla, the company, Mozilla?
Firefox?
Firefox, OK. So we like to do things in the open, so everything you see here is going to be open source. In fact, we have a link at the end. Yes.
Now, we're not going to try and bore you with code examples. For the other engineers out there, we know you're there. We like code examples, too. Mm-hmm. At the end, there's going to be a link for you. It's going to have all of our code examples,
so you take a
including
picture of that at the end. It's fine.
All of my really just nasty bash shells.
So I encourage you to go take. I encourage you to go take a look at this. Spoiler alert: it's basically just a bunch of Python applications and some configuration wrapped around some databases we found lying about on the internet. So I can't speak to their provenance. It's 12-factor S?
It's 12-factor S. So with a show of hands, how many people know what 12-factor?
12-factor, everybody? 12-factor?
Okay.
Okay, not bad.
Good hand.
Not bad.
So if you haven't looked at it, it's essentially a great write-up by the folks at Heroku. Thank you for writing that. That describes what a modern application would look like. So you want to keep it modular, scalable, and safe to deploy.
That's right.
And so if you follow those rules, you basically do it.
You already won the battle. It's awesome. But what is the battle? Well, some context. Back in the day, there were a lot of moving parts.
Wow.
This is actually a simplified version of the Socorro stack as it once existed. As you can see, there's a little Firefox there. There's some collection. It's got some Rabbit in there, HBase, middleware, LDAP for some reason.
I bet there's even like an area for fax in there somewhere, Frosty.
Yeah, it's terrible. This is terrible. But somehow it works for the most part.
Right.
When you've got this much stuff, it's going to break. Something's going to break, right? And Eleanor, right, she touched on this a little earlier, right?
She said it really well.
The myth of things working all the time, it's a myth.
It's a myth.
Right? So the simple fact of the matter is that failure has to be an option.
Oh, it's absolutely an option, Frosty.
Serious option.
Oftentimes the default option.
So practically speaking, this means the code base. It means everything in the code base has to buffer, spool, cache, retry, fail gracefully, or at least fail in predictable ways.
Yeah. I mean, and we've gotten really good at that, actually.
Well, yes, yeah, well, I'd like to think we've gotten okay at that. Now, I'd like to say that we designed Socorro this way because we're really good programmers.
Aren't we?
That's true. And that we design really good software. But the real reason is it's because HBase, we had 99 problems, and HBase was most of them.
Yeah.
All right, that's a fact. It's a fact. But we had a code base that was generally only, it was generally okay.
Seems reasonable.
Okay, yeah.
Seems reasonable.
We did try to replace HBase that one time, though, right?
Yeah. Well, how did that go?
Well, I actually got a very short story I'd like to tell about that time we tried to use
God it was short.
CEPH.
All right,
it started.
so we landed.
We came in for it's just a little bit of fire. It's still good.
No, we're
it's
fine.
Still good.
This is,
oh God! Oh
yeah,
God!
yeah.
Okay, bail out. We're done.
All right, at least we got out there. At least
done.
we got out.
This didn't work out how we wanted, but we did. We bailed out. It's fine.
Yep.
That's
Safety
my short
features
story
of
about
CEPH.
CEPH. This is not the real problem, though. The real problem is one day, word came down from on high that the end of the world was coming.
Oh, geez. This sounds pretty apocalyptic,
This
Frosty.
sounds bad, doesn't it? So the vast majority of crash stats was located at a single data center.
Yes,
Whoops.
one data center.
Okay, that's
Kind
the
of
first hint.
ironic
We're maybe
having
not the
the-
greatest engineers on Earth,
The
but okay.
system for failures in one data center, but
The contract for this data center was going to be left to expire. We have some other data centers, but we had no more capacity at those data centers. So basically,
go.
C-levels came to us and said, I don't care where you go, but you can't stay here. So when your world is going to end,
yeah.
what happens? I mean, do you panic?
Well, absolutely.
Yes, there's a little bit
for
of
quite a
panicking.
while. We're definitely going to panic.
We're definitely going to panic.
But then we're going to maybe think about terraforming ourselves a new planet.
A new world.
Again, nothing to do with Star Trek.
Fair use policy. All right. So this presented a unique opportunity, didn't it?
Yeah, well, we were able to say all of these great things. I mean, they're developers. You say what you want about them, but they do have some good
I do say
ideas
what I want about
sometimes.
them.
I know, I do too. And they've got some pretty great ideas, right? They've been doing a lot of things that we in the infrastructure world could really learn from.
Right. Well, they said is they wanted continuous delivery, and we thought, well, geez,
I want that.
wouldn't that be good for infrastructure too? Is that even possible?
I'd like some modern stuff, Frosty.
Modern stuff, right? So let's talk about continuous delivery for a second. Continuous delivery is scary.
Well, it feels scary, right?
It feels scary. Why does it feel scary, JP?
So making a change is obviously going to be a lot scarier than not making a change, right? But everyone here, your job, my job, Frosty, your job, is literally to make changes.
That's what we do.
And so there's kind of a bit of a juxtaposition there that's really scary. And so this continuous delivery stuff, it feels scary because you're going to be doing that, but this is the safe way of making changes.
Which we'll get into. But really, the deal here is trust, isn't it? Right? That's what's scary. You have to trust the code. You have to trust the tools. You have to trust the infrastructure.
The monitoring.
The monitoring.
The data.
The data, the tests. But most importantly, you got to trust the people around you. And that's
Developers,
not easy.
God help us.
Right? Especially when there's no communication and nobody in oversight, nobody has any accountability. Trust is hard to come by. Now, it's time for some brutal honesty, all right? Continuous delivery has not seen particularly widespread adoption within Mozilla.
We're getting there.
As an organization, we're moving inexorably in this direction.
And in fact, Frosty, we're about to start shipping certain parts of Firefox in continuous delivery methods. So if we're able to do it for our giant honking 450 million user base.
No, it's bigger than that.
Is it bigger now?
That's what we tell ourselves.
Okay.
So.
That's what I like to hear.
Actually, and this was funny, so Eleanor touched on this earlier about catching bugs, right? Continuous delivery is going to help you to catch bugs early. So our esteemed colleague Rod Helmer has a great quote about this. He says, bugs are more expensive the further out in the process you are. So if a developer catches a bug in their own code, that's relatively inexpensive.
Fantastic job,
It's a
developer.
couple of cents or dollars or whatever it took them to find
Great
out.
work.
Thank you. The reviewer could catch it in PR, and it's a little more expensive because now there's 2 people, and it's a little bit more time, but it's still
It's pretty awesome that it's getting reviewed.
Right? The bug could be caught in stage, and that's still somewhat expensive, but it's not so bad because you got it before it went to prod.
I'm glad the developer went to staging.
But it could go to prod, and then you're talking real money,
does.
right? That could be real dollars and cents, euros, whatever, and that's going to cost you. But it's not the worst place to catch a bug.
No, I've seen
The
worse.
worst place to catch a bug is when everything is on fire, and the rule of law is a blissful memory, and we're all single combat in like a Thunderdome-style scenario. That's an expensive bug.
Those days are fun.
But it's not the most expensive bug. The most expensive bug is what happens after that. The bug is now a feature, and you're stuck with it.
I think we've actually got a few products like that.
I think we have products that are entirely feature bugs.
Yeah.
So, What we had going into this, in our old world that was about to disappear, was an old and busted human stack, right? How did this work?
Well, essentially, we had a group of developers who were writing great code.
Great code.
Potentially. And then they would have to interface with our operations staff through Bugzilla, and I'm also sorry about that.
Sorry about Bugzilla.
We've got a great opportunity to move that product forward. But essentially, their surface area for deployment was doing a bug, and then it was throwing that pig over the wall.
And that could be a day,
right?
it could be a week, it could be a month. There was a general lack of communication between this sort of classic siloed scenario, right? In other words, a lack of trust. There was no accountability.
Well, everybody could just push to production, file that bug, right? Go home on a Friday afternoon, and it was a lot of people in this room, have had similar experiences, I bet, where that becomes our weekend.
Good times, guys, good times.
Thanks for the fun.
Good time, group. So, we had this old and busted stack. We wanted to move to a new stack.
Oh, this looks awesome.
Now, this was just an idea. This was like, we were thinking, like, what would a perfect world that we're going to terraform look like? Let's imagine. We want a system where trust is inherent. It's built in. And who drives that?
Well, it needs to be developer-driven for us.
right.
You see, the thing is having us making the decisions for their code, for their changes, doesn't really make much sense anymore, does it?
You want to have that strong feedback loop. You want to build an environment where everybody feels a sense of accountability, a sense of pride, a sense of ownership. And you need that strong feedback loop. You need that strong level of trust and communication between people. That's super, super key. And this is what we kind of were envisioning. And then we thought, well, wait a minute. As long
that does sound good, yeah.
It sounds pretty good, but as long as we're, what could we in the magical world of the future? What are the things that we want?
Well, I mean,
we
now that you
wanted
asked,
things,
thank you for asking.
We wanted things developers already had.
Yeah. Well, there's all these neat tools now, right, to be able to track your audit trail whenever we have a problem. What's the one thing we always ask? Who the hell did what?
Who can we blame? No.
And then there's
postmortems.
Lots of nice tools, right, to do version control, to keep your infrastructure as code.
Yes,
and peer review. And Frosty, I should apologize to you for all my nasty bash.
It is
You're the one who had to review it.
It's nasty bash.
Style guides is not my strong point. And so there were other tools, though, like CloudFormation. Anybody use CloudFormation?
CloudFormation? Anybody?
How many days have you spent checked into the psych ward because of all that JSON?
JSON-related mental anguish, we needed less of that. We wanted version control, we wanted peer review, we wanted an audit trail, and we wanted to deal less with JSON, and we wanted to do this from an infrastructure perspective. Maybe?
all sounds awesome.
Is that a thing that could happen? I don't know, I guess.
We should try and design that.
Let's design this. What might this look like? It might look like this.
Now, this is one of our featured slides. We're really, really quite good as designers. Even though we're usually DevOps, we're also really good designers.
Solid graphic design skills.
And so you can see we've only got good developers here.
Only the good devs are Git pushing.
Yeah.
Only the good ones. But the exact details here is not that critical. The whole idea is the surface that
Well, it's
developers are
developer-driven
interacting
right
with.
there, isn't it?
Exactly. The developer pushes a nice tagged release to Git, and all of a sudden everything else happens.
Yeah, well,
right?
that was a hard requirement. We had, two hard requirements, really. We had that everything's going to catch on fire and burn down probably
That's
requirement. And then we had a requirement where our developers, the surface area that we wanted them to have is the same surface area they already have pushing code to GitHub.
Exactly. But there's a lot of things going on here that are automated, right? There's a lot of stuff going on here that doesn't require a human.
Developers.
How do we know what's going on there? You got to look, right? Who watches the watchers? Or a watch service never fails. Now,
Never.
the details here, not important. These are the ones we happen to use on this project. The critical thing here is that you use some form of like monitoring, metrics, data collection, and use more than one.
Multiple ones, right? When the first monitoring fails, it's great. You get to stay asleep. You don't get paged. But then there are some repercussions sometimes, which kind of sucks.
The key thing here is why. Why do we need to use multiple tools that do different types of things? Now, again, there's a lot of great monitoring tools out there. The important thing is context, right? Getting the right data to the right people at the right time so they can make decisions, move things forward. And that means
Which people?
Everybody.
Okay, so
right?
not just us?
Not just us, not just the devs.
Okay.
Project managers, product managers, salespeople. Get that
even our
contextual
boss?
information in front of them. Well, yeah, maybe.
I guess.
All right. We'll let him in on it. You want to know when things broke. That's good, right? Nagios will tell you when something's broken. But knowing how things worked is better. When you push a change and nothing breaks, what did you do, right?
Well, I'm sure it was really good.
I'm sure, well, only the good devs are pushing changes. We know this.
Yeah.
But when they push a change, what happened? And that's why you want to have those tools. Wait a minute. So we have a cycle. We push a change. We analyze the results. This feels sort of sciencey.
Well, if you know how you're doing right now,
It feels sciencey.
right? And you know what you changed. We talked about having that audit trail of who the hell was just doing what. And then you know how you're doing afterwards because you see which alerts are going red, which alerts have gone green. That's kind of
So the scientific method, for those of us like myself who've been out of school for a while, goes like this. Ask a question. Make a hypothesis. Make a test, right? Analyze the results, make a conclusion, communicate the results of that, more or less. So we thought, could we be sciencey? Propose a change. That's like commit some code. Yeah. We've got a bunch of tests, right? We push that to stage, analyze the outcome. Oh, that sounds good. Conclude that the change, hopefully, is a good change.
Smashingly good.
Smashingly good. And then rinse and repeat. Oh my God. All of a sudden, it's all starting to come together. But what does this mean practically speaking?
Well,
right?
essentially, we're going to want to collaboratively review all of the horrible bash that I've written.
Do we really want to collaboratively review that?
We should. We probably should review it.
We probably should review it. We want to review those infra changes before they're applied. We want to use templates so the deployment artifacts are consistent over time so that we can run fair tests, another important element of the scientific methods. It's sciencey, right? Automate the actual application of those changes so we can avoid human error.
Frosty doesn't like this slide.
He made me do that. Distribute. And when, of course, we distribute, then and apply, so communicate the results of that test, right? Distribute and apply the known good configuration updates. And all of a sudden, we're like, oh my God, we can use the power of science. Amazing.
Well, were we ever able to do that?
Well, actually, let's talk about that.
Okay.
So we built this thing, and how we built it is, you can learn about that in the slides afterwards, not the slides, the link afterwards. But we do have a story to tell about that. It's Migration Saga, Part 1.
It went really well, and everyone lived happily ever after,
Anyways,
right?
that's the end of our talk, thanks. Oh, wait, no, it didn't go super great.
Oh, yeah. So we went ahead and we started flipping over to
AWS in this case.
Yeah, AWS. And everything was going great. We were getting about 60 requests per second from people using Flash. And, that's what we were seeing in our monitoring on our old systems. And we moved over, and
all of a sudden,
30 requests per second.
All
what
of a sudden,
happened to
we
half
lost
the traffic?
half of our traffic
when
we flipped over. Wow, that's not great. So the wailing and gnashing of teeth and the opening of Red Bulls.
A lot of Red Bulls. And I stayed up all night and started doubting the very existence of a common fabric of reality, thinking Einstein was wrong.
Turns out, though,
he was right.
Turns out he was right. Who knew?
Our monitoring was right.
And our monitoring was right. It caught a bug in our old infrastructure.
That
we were
double
counting all of our traffic for years, and we didn't know.
And this new sweet monitoring showed us. I only wish it had been like 24 hours earlier and 20 Red Bulls before that.
The problem is that when we lost half of our traffic, or so we thought, we switched everything back. So we had to do that. So we had to migrate again, which we did a few weeks later. Migration Saga Part 2. We were at this all hands, high in the mountains of British Columbia, away from civilization.
Very little internet.
Very little internet. Well, it was hotel Wi-Fi as far as the eye could see. We had limited ops support because the ops were there also drinking.
As in none.
I'm thinking to myself, what better time to migrate to AWS?
Show that we are confident about this.
In the immortal words of Prodigy and Havoc, there ain't no such thing as halfway ops.
Yes.
All right?
I'm not sure
that's the time
exactly
to do
what
it.
They said,
that's exactly what they said, and it's also exactly what Shakespeare said. So we opened a bottle of scotch, hit play, and we felt very confident.
Right, and we see
very confident
in the
about
photo
this.
Our head of engineering.
We had high degrees of confidence.
Oh, our
going into
esteemed colleague Rob Homer. You can see the deployment scotch there, and wasn't doing its job.
Here's the thing, though. It worked out really well. We migrated over, and in fact, we're still there today. And we're running everything in Amazon.
Really great.
And it's working really nicely. And I guess
it's amazing.
It's amazing. Is that the end of our talk?
No,
it's not all sunshine and rainbows. There are some problems. All right, cloud management tools are great, but they can't see the future.
We use Terraform. We like it quite a bit. Same with CloudFormation.
There's lots out there.
Lots of tools, but
they can't tell you when they hit API thresholds.
Yeah.
Right.
Sometimes AWS doesn't either.
Sometimes AWS doesn't. Sometimes AWS is a dirty liar. Account limits. Incomplete implementations of the API, these are problems, right? And if you're using tools that are sitting between you and the end service, this is stuff you're going to hit. So, got to deal with that. We don't currently have a good parallel testing story. Every commit that goes in, even if it's like just to change some documentation, you got to go through the whole test process, and that kind of sucks.
It takes a while.
So that's something that we would like to work on, and we're going to be hanging out here for the rest of the day. So if you've got ideas on how to do nice, like parallel testing stuff, we'd really like to talk to you about that. There's another problem.
Well, another opportunity.
Another opportunity. Long-running instances, like Elasticsearch and Jenkins and stuff that's like really full of state.
I've actually got a pretty good strategy for that.
Do you have a good strategy for that?
Yeah, so all you really need, and this is a strategy I think probably a lot of you already know, you need about 6 square feet of space, and then you just lay down. You try not to cry. It is recommended to hold onto your legs for safety and have a napkin around. But no, seriously, if you have a better process than this,
for dealing with stateful data in the cloud,
come talk to us.
We want to talk to you.
Or if you just need someone to lay down with and cry.
We're here for you for that, too. We can have a little session. That said, honestly, it's mostly sunshine and rainbows.
Pretty happy times.
We started with a multi-step, excessively manual, error-prone, highly dangerous, a very bad, no good deployment and management cycle.
Full of opportunity.
Full of opportunity. We ended up with a highly automated cycle. It's fast, it's buzzwordy, it's modern, it works great, and we love it, and everybody loves it, except when they don't. But it's mostly sunshine and rainbows. And that's it. Is that the end of our talk? Actually, no, wait. There's one more slide.
There is.
So this one I'll leave up just for a quick second. If you want to take a picture, write it down. We didn't want to, bore you to sleep at, 4 p.m.
Yeah, that's not
How
4 p.m.
about, ignore that, human error. And here is the link. It's just basically like a blog post, and we've got all the code examples and links to our repos, and you can see everything that we did. It's all in the open.
Including all of my nasty bash.
Including all of JP's nasty bash. It's all there. And I guess no, wait, there's one more. I'm a classy guy.
Yeah, we better end this right, Frosty.
And classy guys end talks with Shakespeare quotes. So here we go. A warming peace this afternoon with it brings. The developers, for happiness, will deploy directly from head. Go hence to have more talk of these happy things, for some shall be pardoned and some praised. For never was there a tale of more joy than this of Mozilla and the DevOps. Thank you very much.
Thank you, Frosty. Thank you.
Thank you very much.